Hello there and welcome to the Sleep with Stories channel. I'm so glad you found your way here. Maybe you had a long day, or maybe you're the kind of person who likes falling asleep to the quiet rhythms of our planet and the ancient mysteries of the ground beneath your feet rather than counting sheep. Either way, tonight's journey is for you. You've got nothing to do but rest. Let your mind relax, your breathing slow, and your body grow light as if the very gravity of the world has softened. Tonight, we explore the vast, living story of our home. These are 100 sleepy facts about the Earth. Now let's begin. The first 10 echoes of the Earth. 1. The Earth is not a perfect sphere, but an oblate spheroid. Because the Earth spins at such high speeds, over 1,600 kilometers per hour at the equator, it actually bulges outward at its middle. This means the distance from the Earth's center to sea level is roughly 21 kilometers greater at the equator than at the poles. If you were to stand at the North Pole, you would technically be closer to the molten heart of our planet than someone standing on a tropical beach in Ecuador. It is a world that has been stretched and shaped by its own restless rotation over billions of years. 2. We are currently breathing air that has been recycled for millions of years. The nitrogen and oxygen molecules currently entering your lungs have likely been through the respiratory systems of dinosaurs, ancient forests, and long-extinct sea creatures. The Earth's atmosphere is a closed loop, a delicate veil held in place by gravity that has been processed and reprocessed by every living thing that ever walked the surface. Every breath is a connection to the deep history of the planet, a quiet cycle that continues while you sleep. 3. The Earth's magnetic field is a shifting, invisible shield. Deep within the planet, the motion of liquid iron and nickel in the outer core creates a massive dynamo effect, generating a magnetic field that stretches far into space. This field protects us from the solar wind, a stream of charged particles from the sun that would otherwise strip away our atmosphere. This shield is not static. The magnetic North Pole is currently drifting towards Siberia at a rate of about 55 kilometers per year, a reminder that the world beneath us is constantly in motion. 4. Most of the Earth's gold and platinum is hidden in its core. During the planet's violent formation, the Earth was so hot that it was almost entirely molten. In this liquid state, heavy metals like gold, platinum, and iron sank toward the center due to their density, leaving the outer crust relatively poor in precious metals. Geologists estimate that there is enough gold in the Earth's core to cover the entire surface of the planet in a layer 1.5 feet thick. We live upon a treasure chest that is forever out of reach. 5. The deepest part of the ocean could easily swallow Mount Everest. If you were to take the tallest mountain on Earth and drop it into the Mariana Trench in the Western Pacific, its peak would still be more than 2 kilometers underwater. The trench reaches a depth of about 10,935 meters. At the bottom, the pressure is over 1,000 times that of the surface, equivalent to having an elephant stand on your thumb. It is a silent, dark, and pressurized world that remains more mysterious to us than the surface of the moon. 6. Earth is the only planet in our solar system not named after a deity. While Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune all carry the names of Roman and Greek gods and goddesses, the word Earth comes from the Old English and Germanic words Eorth and Eartha, which simply mean the ground. It is a humble name for a world that is, so far as we know, the only place in the vastness of the cosmos where life has found a way to flourish and dream. 7. The Earth's crust is actually a collection of massive, drifting puzzles. We often think of the ground as solid, but the Earth's outer shell is broken into several large tectonic plates that float on the semi-liquid mantle below. These plates move at about the same speed that your fingernails grow. Over millions of years, this slow drift has torn continents apart and crashed them together to form mountain ranges like the Himalayas. The map of the world we see today is merely a single frame in a very long and slow-moving film. 7. The Earth's crust is actually a collection of massive, drifting puzzles. We often think of the ground as solid, but the Earth's outer shell is broken into several large tectonic plates that float on the semi-liquid mantle below. These plates move at about the same speed that your fingernails grow. Over millions of years, this slow drift has torn continents apart and crashed them together to form mountain ranges like the Himalayas. The map of the world we see today is merely a single frame in a very long and slow-moving film. 9. The Earth's day is gradually getting longer. Because of the Moon's gravitational pull on our oceans, the Earth's rotation is slowing down ever so slightly. Every century, the length of a day increases by about 1.7 milliseconds. When the dinosaurs were roaming the Earth, a day was only about 23 hours long. In the very distant future, the days will be longer still, giving the inhabitants of the Earth even more time to witness the slow turning of the stars. 10. Earth is the densest major body in the solar system. Despite being smaller than the gas giants like Jupiter or Neptune, Earth is incredibly heavy for its size. This is due to our massive metallic core and the compact nature of our rocky layers. With an average density of about 5.51 grams per cubic centimeter, the Earth is a solid, heavy anchor in the void, providing the perfect gravitational platform for oceans to rest and for life to take root. 11. The Earth is home to a great oxygenation event that was once a mass extinction. About 2.4 billion years ago, the Earth's atmosphere underwent a radical transformation that changed the chemistry of the world forever. Early life consisted primarily of anaerobic organisms that found oxygen to be a deadly poison. However, ancient cyanobacteria in the oceans began producing oxygen as a byproduct of photosynthesis. For millions of years, the minerals in the crust absorbed this oxygen, but eventually the land became saturated and the gas began to flood the atmosphere. This oxygen catastrophe wiped out most of the life on Earth at the time, but it cleared the stage for the rise of complex, oxygen-breathing multicellular organisms, including the ancestors of the very animals and humans that walk the Earth today. 12. There is a hidden ocean locked hundreds of kilometers beneath the crust. While we marvel at the vastness of the Pacific and Atlantic, scientists have discovered evidence of a colossal reservoir of water trapped 400 to 600 kilometers underground in the Earth's mantle. This water isn't in a liquid pool like an underground lake. Instead, it is chemically bound inside a rare, blue, sponge-like rock called ringwoodite. Geologists believe that if only 1% of the mantle's weight is water, it would represent a volume 3 times greater than all the water in the oceans we see on the surface. This deep earth water acts as a lubricant for plate tectonics, allowing the continents to shift and the planet to remain geologically alive, rather than becoming a stagnant, dead rock like Mars. 17. The Earth's atmosphere has a secret outer skin that breathes along with the sun. Far above the clouds where we live, the Earth's atmosphere extends much further than most people realize, reaching out into a region called the thermosphere and eventually the exosphere. This outermost layer is incredibly thin, yet it is highly sensitive to the sun's activity. During periods of high solar radiation, the entire atmosphere actually expands outward, swelling like a giant balloon as the gases heat up. Conversely, during solar minimums, the atmosphere exhales and shrinks back toward the surface. This invisible breathing means that satellites in low Earth orbit experience varying amounts of drag, slowing down or speeding up depending on the sun's temper. Beyond that, there is a region called the geocorona, a cloud of hydrogen atoms that stretches nearly 630,000 kilometers away, meaning the Moon actually orbits inside the outermost wisps of the Earth's atmosphere. We are not just a rock in a vacuum. We are a planet wrapped in a vast, ethereal veil that reaches out to touch the lunar surface. 18. The Earth's ring of fire is a testament to the planet's restless, churning interior. Deep beneath the Pacific Ocean lies a 40,000-kilometer horseshoe-shaped string of volcanoes and oceanic trenches known as the Ring of Fire. This isn't just a random collection of mountains. It is the site of nearly 90% of the world's earthquakes and home to 75% of all active volcanoes on the planet. It exists because the massive Pacific tectonic plate is constantly colliding with and sliding underneath the surrounding continental plates in a process called subduction. As the seafloor is forced deep into the Earth's scorching mantle, the rock melts into magma and rises back up, bursting through the surface to create violent eruptions and towering mountain ranges like the Andes and the Cascades. This constant recycling of the Earth's crust means that the ground you walk on is technically being consumed and reborn over millions of years, a grand, slow-motion engine of creation and destruction that ensures the Earth remains a geologically vibrant world rather than a cold, stagnant desert. 19. The Earth's albedo effect is a delicate thermal balance that regulates your sleep environment. Everything on the Earth's surface has a specific albedo, a measurement of how much solar energy it reflects back into space versus how much it absorbs as heat. Fresh snow has a very high albedo, reflecting up to 90% of sunlight, which is why polar regions stay so cold even during the long summer days. In contrast, the deep blue oceans have a very low albedo, absorbing about 94% of the sun's energy and turning it into heat. This creates a powerful feedback loop. As ice melts due to warming, it reveals darker ocean water or land underneath, which then absorbs even more heat, causing more ice to melt. This balance of light and dark, reflection and absorption, acts as the Earth's global thermostat. It is a fragile equilibrium that has kept the planet's temperature within the narrow range required for liquid water, and therefore life, to exist for billions of years. As you lie in the darkness of your room, you are benefiting from a planetary cooling system that has been finely tuned by the color of the clouds, the whiteness of the ice, and the deep shadows of the sea. 20. The Earth's deep time is recorded in the Grand Canyon like a vertical library of the world. When you stand at the rim of the Grand Canyon, you are looking at nearly 2 billion years of planetary history etched into the rock walls. The river at the bottom, the Colorado, has spent the last 6 million years acting like a giant sandpaper, carving through layers of limestone, sandstone, and shale to reveal the great unconformity. This is a mysterious gap in the geological record where hundreds of millions of years of rock layers have simply vanished, likely eroded away during the snowball Earth periods we spoke of earlier. The rocks at the very bottom, known as the Vishnu basement rocks, are so ancient that they formed before the first complex life even existed on this planet. To look down into the canyon is to look backward through the deep time of the Earth, seeing a physical manifestation of the slow, patient process of sedimentation, compression, and upheaval that has built the world we stand on today, one grain of sand at a time. 21. The Earth's Great Green Wall of the Amazon creates its own weather and rivers in the sky. The Amazon rainforest is often called the lungs of the planet, but it is also a massive biological water pump. The trees in the Amazon perform a process called evapotranspiration, where they pull water from the deep soil and release it into the atmosphere through their leaves. A single large tree can release over 1,000 liters of water into the air every single day. This massive amount of moisture creates flying rivers, invisible currents of water vapor in the sky that carry more water than the Amazon River itself. These aerial rivers travel across the continent, bringing rain to regions thousands of kilometers away that would otherwise be deserts. It is a self-sustaining system where the forest literally creates the rain it needs to survive. As you drift off, imagine these vast, silent rivers of mist flowing high above the canopy, a testament to how life on Earth doesn't just adapt to its environment, but actively shapes and nurtures it. 22. The Earth's Chandler wobble is a tiny, mysterious shiver in the planet's spin. In addition to the long 26,000-year wobble of the Earth's axis, our planet also experiences a much smaller, more erratic tremor known as the Chandler wobble. Every 433 days, the Earth's poles shift by a few meters in a circular motion. For over a century, scientists were baffled by what caused this planetary shiver, as friction should have caused it to die out long ago. Recent research suggests that the culprit is the varying pressure of the ocean floor and the changing salt content of the water, combined with the way the wind moves across the surface. Essentially, the Earth is so finely balanced and so fluid that the sloshing of the oceans and the push of the breeze are enough to make the entire 6 sextillion-ton planet tilt slightly on its axis. It is a reminder that the Earth is not a rigid, unmoving statue, but a sensitive and reactive body that vibrates in response to the movement of the air and the tides. 23. The Earth's deep carbon cycle is a multi-million-year heartbeat that prevents the planet from freezing or frying. While we often focus on the carbon moving through our breath and the trees, there is a much slower, more profound cycle happening deep within the Earth's interior. Over millions of years, carbon is pulled from the atmosphere by rain and stored in rocks on the ocean floor. These rocks are then dragged deep into the Earth's mantle at subduction zones, where they melt and eventually find their way back to the surface through volcanic eruptions. This process acts like a giant, slow-moving planetary lung, regulating the amount of carbon dioxide in the air and keeping the Earth's temperature stable enough for liquid water to exist for billions of years. Without this internal recycling, the Earth might have ended up like Venus, trapped in a runaway greenhouse effect, or like Mars with an atmosphere too thin to hold on to heat. It is a quiet, geological rhythm that ensures the world remains hospitable while we sleep. 24. The Earth possesses time capsules in the form of zircon crystals that are older than the continents. Deep within the crust, scientists have found microscopic grains of a mineral called zircon that are a staggering 4.4 billion years old. These tiny, nearly indestructible crystals formed when the Earth was just a toddler in cosmic terms, barely 150 million years after the planet itself coalesced from the solar nebula. By studying the chemical impurities trapped inside these zircons, geologists have discovered that even in its earliest infancy, the Earth had a solid crust and perhaps even liquid water. This contradicts the old idea that the early Earth was a hellish, molten landscape for a billion years. Instead, these crystals tell a story of a planet that cooled and became a water world much earlier than we ever imagined. Each tiny grain is a witness to the very first moments of our home's existence, surviving through eons of heat and pressure to tell us where we came from. 25. The Earth's great unconformity is a missing chapter in the book of the world. In rock formations all over the globe, there is a strange and silent gap known as the Great Unconformity, where a massive section of the geological record has simply vanished. In some places, like the Grand Canyon, rocks that are 500 million years old sit directly on top of rocks that are 1.7 billion years old. Over a billion years of history, nearly a quarter of the Earth's life has been erased from the stone. Scientists believe that during the snowball Earth phase, massive glaciers several miles thick acted like giant celestial bulldozers, grinding away the surface of the continents and dumping the remains into the deep oceans. This missing time represents a period of profound mystery, a silent era where the Earth was undergoing a radical transformation that eventually led to the sudden appearance of complex life. It is a reminder that even the solid Earth can lose its memory, leaving us to wonder about the secrets hidden in the billion-year silence. 26. The Earth's soil is a living skin that takes centuries to create but only moments to lose. Beneath the grass and the pavement lies a complex, biological universe that is the foundation for almost all terrestrial life. To create just one single inch of topsoil, it can take the Earth between 500 and 1,000 years of patient labor. This process involves the slow weathering of solid rock by wind and rain, the persistent burrowing of earthworms, and the microscopic breakdown of organic matter by billions of fungi and bacteria. Soil is not just dirt. It is a massive, carbon-storing filter and a biological pharmacy. A single tablespoon of healthy soil contains more living organisms than there are people on the planet. As you rest tonight, remember that you are supported by a thin, ancient crust of life that the Earth has been meticulously weaving together since the first plants crawled out of the sea. 27. The Earth's core mantle boundary is a landscape of mountains and valleys more dramatic than the surface. Nearly 2,900 kilometers beneath your feet, where the solid rock of the mantle meets the liquid iron of the outer core, there exists a world of extreme topography that we are only just beginning to map. Using seismic waves from earthquakes as a kind of planetary ultrasound, scientists have discovered ultra-low velocity zones, massive, continent-sized blobs of dense material that rise like subterranean mountains. Some of these structures, known as large low-shear velocity provinces, are taller than Mount Everest and wider than Australia. They are the roots of the world, remnants of ancient chemical reactions from the Earth's birth. This hidden landscape, glowing with white-hot heat and crushed by unimaginable pressure, is the engine that drives the movement of the continents and the rising of volcanic plumes far above. 28. The Earth's atmospheric tides are caused by the sun, not the moon. We are all familiar with the way the moon pulls on the oceans to create the tides, but the Earth's atmosphere also experiences tides of its own. However, these are driven primarily by the sun. As the sun heats the atmosphere during the day, the air expands and creates a thermal tide that ripples around the planet. These waves of pressure cause the entire atmosphere to bulge and oscillate in a predictable rhythm twice a day. While we cannot feel these subtle shifts in pressure, they are powerful enough to influence global wind patterns and even the timing of rainfall. It is as if the planet itself is breathing in a slow, solar-powered cadence, a rhythmic heartbeat of air that ensures the heat of the equator is distributed to the colder corners of the world while you sleep in peace. 29. The Earth is a dust collector that gains weight from the stars every day. Even though the Earth feels like a self-contained world, it is constantly being showered by material from deep space. Every single day, approximately 60 to 100 tons of cosmic dust and micrometeorites fall through our atmosphere and settle on the surface. Most of this material is no larger than a grain of sand, the tiny debris left behind by passing comets or the ancient collisions of asteroids. This means that every time you take a step outside, you are likely walking on a microscopic dusting of stardust that has traveled for billions of miles through the vacuum of space to find a home here. Over the course of a year, the Earth gains about 40,000 tons of mass from this celestial rain, slowly adding the elements of the wider universe to the composition of our own soil. 30. The Earth's deep gold was delivered by a cataclysmic meteor bombardment. The gold that we find in the Earth's crust today, the precious metal used in our jewelry and technology, should technically not be there. Because gold is so dense, it should have all sunk into the Earth's molten core during the planet's infancy, billions of years ago. Geologists believe that the gold we mine today arrived much later, during a period known as the Late Heavy Bombardment. Around 4 billion years ago, a massive storm of meteors slammed into the Earth, salting the cooling crust with precious metals. This means that every ounce of gold ever found was forged in the hearts of dying stars, hurled through space, and delivered to Earth in a firestorm of ancient impacts. We are living on a planet that has been decorated by the debris of the cosmos, a world built from the wreckage of the stars. 31. The Earth's great hydrological cycle is a planetary masterpiece of water transport and purification. As you rest, the Earth is engaged in a colossal engineering project, the movement of over 500,000 cubic kilometers of water through the atmosphere every year. The sun acts as a giant engine, evaporating water from the salty oceans and stripping it of its impurities, lifting it into the sky as pure, fresh vapor. This moisture is then carried by global winds, forming clouds that act as vast, floating reservoirs. When this water eventually falls as rain or snow, it feeds the rivers, replenishes the aquifers deep underground, and sustains every living cell on the continents. This cycle is so efficient that the same water molecules that are in your glass today have likely been through the Earth's atmosphere-to-ocean loop over 8 million times since the planet formed. It is a closed, eternal system of renewal that ensures life never runs out of the vital fluid it needs to survive. A silent, splashing rhythm that blankets the world in a life-giving mist while the cities are quiet. 32. The Earth's cryosphere acts as a giant, reflective mirror that keeps the planet's heart cool. The cryosphere, the portions of the Earth's surface where water is in solid form, including glaciers, ice caps, and permafrost, is much more than just a cold wasteland. It is a vital component of the Earth's climate control system. Because ice and snow are bright white, they possess a very high albedo, reflecting up to 90% of the sun's incoming solar radiation back into space. This prevents the Earth from absorbing too much heat and keeps the global temperature within a narrow, habitable range. Furthermore, the massive ice sheets of Antarctica and Greenland are so heavy that they actually depress the Earth's crust, pushing it down into the mantle by hundreds of meters. If all this ice were to melt, the land would slowly rebound or rise upward in a process that takes thousands of years. The cryosphere is a silent, frozen guardian, a shimmering shield of white that sits at the poles, reflecting the harshness of the sun and maintaining the cool, stable environment that allows the rest of the planet to flourish in a gentle, green balance. 33. The Earth's plate tectonic thermostat prevents the world from suffering a permanent ice age. While we often think of volcanic eruptions as disasters, they are actually part of a sophisticated planetary temperature regulation system. Over millions of years, the Earth's climate is influenced by the silicate carbonate cycle. When the Earth gets too warm, Increased rainfall washes carbon dioxide out of the atmosphere and into the oceans, where it is eventually tucked away into limestone rocks on the seafloor. This cools the planet down. However, if the Earth gets too cold, the rainfall stops, but volcanoes continue to pump carbon dioxide back into the atmosphere from deep within the mantle. This greenhouse gas then traps heat and warms the planet back up. This tectonic thermostat is the reason Earth hasn't ended up like its sister planet Venus, which lacks plate tectonics and suffered a runaway greenhouse effect that turned it into a 475 degrees Celsius furnace. We are kept safe by the slow, churning movement of the Earth's plates, a deep-seated geological pulse that keeps our atmosphere just right for life. 34. The Earth's iron core creates a protective cocoon that reaches thousands of miles into space. Deep beneath the rocky mantle lies the Earth's outer core, a swirling sea of liquid iron and nickel that is as hot as the surface of the sun. Because this molten metal is electrically conductive and constantly moving due to the Earth's rotation, it generates a massive magnetic field known as the magnetosphere. This isn't just a curiosity for compasses. It is an essential shield that deflects the solar wind, a stream of high-energy particles from the sun that would otherwise sandblast our atmosphere into space. Without this magnetic cocoon, the Earth would likely be a dry, dead husk like Mars, which lost its magnetic field and its water billions of years ago. As you sleep, this invisible force field is standing guard, catching solar flares and channeling them toward the poles, where they create the silent, dancing lights of the aurora borealis. You are cocooned in a magnetic embrace generated by a spinning heart of iron 3,000 kilometers beneath your bed. 35. The Earth's bioluminescent oceans reveal a hidden galaxy of light beneath the waves. In the deepest reaches of the Earth's oceans, far beyond where the sun's rays can penetrate, the planet has created its own form of light. Over 75% of deep-sea creatures are bioluminescent, meaning they can produce their own glow through chemical reactions within their bodies. From tiny plankton that sparkle like diamonds when the water is disturbed to the eerie, glowing lures of the anglerfish, the deep ocean is not a place of total darkness, but a world of flickering blues, greens, and reds. This living light is used for communication, hunting, and camouflage in a vast, three-dimensional abyss that makes up 90% of the Earth's habitable space. On certain nights, entire stretches of the ocean surface can glow with a milky sea effect, where trillions of bacteria light up the water for miles, creating a glowing horizon that can be seen from space. It is a reminder that even in the darkest, most hidden corners of our planet, life has found a way to create beauty and radiance, a subterranean fire that mirrors the stars above. 36. The Earth's aerial plankton create a microscopic ecosystem in the clouds. High above the ground, in a region of the atmosphere we often consider empty, exists a vast and invisible world of life. Scientists have discovered that the sky is filled with billions of bacteria, fungal spores, and even tiny insects that are swept up by thermal currents. These aerial plankton don't just drift passively. They play a critical role in the Earth's weather. Many of these microbes act as ice-nucleating particles, meaning their physical structure allows water vapor to latch onto them and freeze, forming the very heart of snowflakes and raindrops. Without these microscopic travelers, the clouds might never release their moisture. As you look up at a passing cloud, you are witnessing a living, breathing biological engine that facilitates the movement of water across the continents. 37. The Earth's phytoplankton are the primary engineers of the air you breathe. While we often give credit to the great forests of the Amazon for our oxygen, at least half of the oxygen in the Earth's atmosphere is actually produced by microscopic organisms in the ocean called phytoplankton. These tiny, plant-like cells drift in the sunlit upper layers of the sea, consuming carbon dioxide and releasing oxygen through photosynthesis. There are so many of them that their collective breath sustains almost all animal life on Earth. Furthermore, when these organisms die, they sink to the ocean floor, taking carbon with them and burying it in the sediment for millions of years. This process, known as the biological pump, is one of the most powerful mechanisms the Earth has for keeping the atmosphere cool and stable. 38. The Earth's silent continental rebound is still happening from the last ice age. The Earth's crust is surprisingly flexible. During the last ice age, which ended about 11,000 years ago, massive glaciers several kilometers thick sat upon northern Europe and North America. The sheer weight of this ice was so immense that it actually pushed the Earth's crust down into the mantle, much like a person sitting on a foam mattress. Even though the ice has long since melted, the land is still slowly springing back up in a process called post-glacial rebound. Parts of Scandinavia and Canada are rising at a rate of about 1 centimeter per year. This movement is so powerful that it can change the path of rivers and the shape of coastlines over centuries. A slow, geological sigh of relief that has been continuing for over 10 millennia. 39. The Earth's dust storms from the Sahara feed the life in the Atlantic and the Amazon. The Earth is a deeply interconnected system where a desert in one hemisphere can sustain a forest in another. Every year, massive plumes of dust are lifted from the Bodil Depression in the Sahara Desert by strong winds. This dust travels thousands of kilometers across the Atlantic Ocean. While it may seem like a simple nuisance, this dust is rich in phosphorus and iron, nutrients that are scarce in the rainforests of South America. Scientists have calculated that the mineral dust from the African desert provides the essential fertilizer needed for the Amazon rainforest to thrive. Without the dry, scorched sands of the Sahara, the Great Green Wall of the Amazon might eventually wither, showing that the Earth's health depends on the balance between its most desolate places and its most vibrant ones. 40. The Earth's deep-sea thermal vents are the planet's original chemical laboratories. On the dark, freezing floor of the deep ocean, there are cracks in the crust known as hydrothermal vents where superheated, mineral-rich water billows out from the Earth's interior. These vents are home to some of the most bizarre life forms on the planet, such as giant tube worms and eyeless shrimp, which survive not on sunlight, but on chemosynthesis. Many scientists believe that these vents were the actual cradles of life, providing the heat and the complex chemicals necessary for the very first cells to form 4 billion years ago. These vents act as a direct link between the molten heart of the planet and the living world above, a reminder that the Earth's internal energy is just as vital to our existence as the light from the sun. 41. The Earth's seismic whisper is a constant low-frequency hum that vibrates the entire planet. Even in the dead of night, when the cities are silent and the winds have died down, the Earth is never truly still. Geologists have discovered that our planet produces a constant, low-frequency vibration known as the hum, a sound so deep it sits far below the threshold of human hearing. This isn't the result of earthquakes or human machinery. Rather, it is a persistent, planetary song caused by the relentless movement of ocean waves. As giant swells crash against the continental shelves and pressure waves interact with the jagged floor of the deep sea, they create a resonant thrum that echoes through the entire 12,742-kilometer diameter of the Earth. It is as if the planet itself is a giant bell that is being struck softly and continuously by the oceans. Scientists use ultra-sensitive seismometers to track this hum, discovering that it changes slightly with the seasons as storms move across the hemispheres. As you lie there, you are resting on a giant, vibrating instrument, a sphere of rock and iron that is perpetually humming in harmony with the tides and the heavy, rhythmic breathing of the Atlantic and Pacific Oceans. 42. The Earth's lithospheric memory allows it to store the chemical signatures of oceans that vanished billions of years ago. We often think of rocks as cold, dead objects, but to a geologist, a stone is a record as detailed as any history book. The Earth's lithosphere, the rigid outer shell, possesses a form of memory through a process called inclusion. When minerals like quartz or diamond crystallize deep within the Earth, they often trap microscopic droplets of the surrounding environment, known as fluid inclusions. These tiny bubbles of gas or water are perfectly preserved time capsules. By analyzing these droplets, scientists have found traces of ancient seawater that existed 3 billion years ago, long before the continents had moved into their current positions or the atmosphere contained enough oxygen for us to breathe. These inclusions tell us that the early Earth's chemistry was radically different, rich in methane and sulfur, and that the very first oceans were likely a murky green rather than a bright blue. The rocks beneath your feet are holding onto the chemical secrets of lost worlds, preserving the scent and the flavor of the primordial Earth. keeping the memory of vanished seas alive within the crystalline structure of the mountains. 43. The Earth's mantle convection is a colossal, slow-motion ballet of fire and stone that reshapes the world's map. Deep beneath the crust, the Earth's mantle is not a solid, unmoving wall, but a vast, churning sea of semi-solid rock that behaves like a thick, glowing liquid over millions of years. This movement, known as mantle convection, is driven by the intense heat left over from the planet's formation and the ongoing decay of radioactive elements in the core. Hot plumes of rock rise slowly toward the surface, spread out, cool, and then sink back down in a process that takes hundreds of millions of years to complete a single cycle. This internal lava lamp effect is the engine that drives plate tectonics. It is the force that tears apart supercontinents like Pangaea and pushes them across the globe to create new oceans. This means that the Earth's surface is constantly being refreshed. The seafloor in the middle of the Atlantic is barely 200 million years old, a mere blink in geological time, because it is being continuously created at mid-ocean ridges and recycled back into the mantle at the edges of the continents. Everything you see, from the tallest peaks of the Alps to the deepest trenches of the sea, is just a temporary feature of this grand, slow-motion dance of heat and gravity that has been turning the planet inside out for 4 billion years. 44. The Earth's stratospheric rivers are invisible currents of gas that protect the chemistry of our air. High above the weather systems we experience, in the calm and thin air of the stratosphere, the Earth maintains a complex system of jet streams and atmospheric rivers that act as the planet's circulatory system. One of the most vital of these is the Brewer-Dobson circulation, a slow-moving current that lifts air from the tropical regions, carries it high into the stratosphere, and then deposits it back down toward the poles. This invisible river is the primary way that the Earth distributes ozone, the molecule that protects us from the sun's lethal ultraviolet radiation. Without this constant, high-altitude transport, the ozone layer would thin out in populated areas, making the surface of the planet uninhabitable for land-dwelling life. This circulation is so powerful that it can trap volcanic ash and chemicals for years, spreading them in a thin, global veil that can cool the entire planet by reflecting sunlight. While you sleep, these high-altitude winds are working silently to filter the sun's energy and distribute the chemical ingredients that keep our atmosphere healthy, ensuring that the air remains a protective blanket for all the life huddled below. 45. The Earth's geothermal breath is an ancient energy source that powers entire ecosystems in total darkness. We are accustomed to the idea that all life depends on the sun, but the Earth provides its own internal sun in the form of geothermal heat. At the bottom of the ocean, along the cracks where tectonic plates are pulling apart, the Earth breathes out superheated water rich in minerals like hydrogen sulfide and iron. These areas, known as hydrothermal vents or black smokers, are home to lush oases of life that exist in a world of 250 atmospheres of pressure and freezing temperatures. Here, giant tube worms that grow up to 8 feet long and yeti crabs with furry claws thrive by hosting billions of bacteria that turn the Earth's internal chemicals into food through chemosynthesis. This means that if the sun were to suddenly go dark, these deep-sea ecosystems would continue to flourish, completely unaffected, powered solely by the radioactive decay and primordial heat trapped within the Earth's core. It is a second, independent biosphere that reminds us that the Earth is not just a platform for solar-powered life, but a self-sustaining engine of creation that provides everything necessary for life to survive in the most extreme, sunless depths of the abyss. 46. The Earth's magnetic ghost and the ancient history written in the seafloor. While we use the Earth's magnetic field to find north today, the planet's magnetic poles have actually flipped places hundreds of times throughout history. When molten lava erupts at the mid-ocean ridges, tiny grains of iron-rich minerals align themselves with the Earth's magnetic field like miniature compass needles. As the lava cools into solid basalt, these needles become frozen in place, locking in the direction of the magnetic field at that exact moment in time. As tectonic plates move apart, they carry these frozen records with them, creating a giant barcode of magnetic stripes on the ocean floor. By reading these stripes, geologists can peer back millions of years to see exactly when the North and South poles swapped, a process called a geomagnetic reversal. These magnetic ghosts are the primary evidence that proved the theory of plate tectonics, showing us that the very ground beneath the sea is a sprawling, magnetic tape recorder that has been documenting the planet's internal shifts since the dawn of the oceans. 47. The Earth's deep ice memory trapped within the ancient glaciers of Antarctica. In the high, frozen plateaus of Antarctica and Greenland, the Earth maintains a perfect, chronological archive of its own atmosphere reaching back nearly a million years. Every year, new snow falls and traps tiny bubbles of ambient air before being compressed into solid ice by the weight of the following seasons. By drilling kilometers deep into these glaciers and extracting ice cores, scientists can recover these ancient air bubbles and analyze the exact chemical composition of the atmosphere from hundreds of thousands of years ago. These cores are like a library of the world's climate history. They contain dust from ancient volcanic eruptions, soot from prehistoric forest fires, and even traces of cosmic dust from passing comets. Through this deep ice memory, we can see exactly how the Earth's temperature and carbon dioxide levels have fluctuated in a long, rhythmic dance, providing us with a blueprint of how our home breathes and changes over vast stretches of deep time, while we remain tucked away in the warmth of the present. 48. The Earth's hidden tides that stretch and squeeze the solid ground beneath your bed. We are all familiar with the tides of the ocean, but the moon's gravitational pull is so powerful that it actually creates land tides as well. As the moon orbits our planet, its gravity tugs on the solid rock of the Earth's crust, causing the ground itself to rise and fall twice a day. While this movement is invisible to our eyes, the solid Earth can actually bulge upward by as much as 30 to 50 centimeters in a slow, silent wave that travels across the continents. This constant stretching and squeezing generates internal friction and heat, contributing to the Earth's geological energy. Even the massive skyscrapers in cities like New York or Tokyo rise and fall by nearly half a meter every day in response to the moon's position in the sky. You are not sleeping on a static, unmoving platform. You are resting on a flexible, elastic planet that is being gently kneaded by the gravity of our celestial companion, a rhythmic pulse of stone that matches the heartbeat of the tides. 49. The Earth's atmospheric Goldilocks zone and the miracle of the ozone layer. The Earth's atmosphere is divided into distinct layers, but the stratosphere holds a specific, thin concentration of molecules that is the only reason complex life can exist on land. The ozone layer. Ozone molecules, made of 3 oxygen atoms, have the unique ability to absorb the sun's high-energy ultraviolet, UVB, radiation. Without this thin, invisible shield, the sun's rays would be strong enough to dismantle the DNA of every living cell, effectively sterilizing the continents. Interestingly, the ozone layer is both a protector and a product of life. It only formed after ancient bacteria flooded the atmosphere with oxygen, which then reacted with sunlight to create this protective sunscreen. This created a Goldilocks environment where the atmosphere is transparent enough to let in the light we need for heat and vision, but thick enough to block the radiation that would destroy us. It is a fragile, self-made shield that wraps around the world, a testament to how life and the planet have co-evolved to create a safe, temperate sanctuary in the harsh vacuum of space. 50. The Earth's primordial heat is a 4.5 billion-year-old battery that is still cooling down. The Earth is incredibly hot at its center, roughly 6,000 degrees Celsius, which is as hot as the surface of the sun. About half of this staggering heat comes from the decay of radioactive elements like uranium and thorium in the crust and mantle. However, the other half is primordial heat, the actual energy left over from the violent birth of the planet. When the Earth was forming 4.5 billion years ago, the kinetic energy of countless colliding asteroids and the gravitational collapse of the planet's mass generated an immense amount of thermal energy. Because the Earth is so large and rock is such an excellent insulator, the planet has been unable to shed all of that original heat into the cold vacuum of space. This means that every volcano, every earthquake, and every movement of a tectonic plate today is being powered by the battery of the Earth's own birth. We are living on the cooling embers of a cosmic explosion, a planet that is still slowly, patiently exhaling the fire of its creation while we sleep on its hardened, peaceful crust. 51. The Earth's deep water cycle reveals that the planet's oceans are constantly being swallowed and exhaled by the mantle. While we are taught in school about the evaporation and precipitation of the water we see, there is a much more epic deep water cycle that operates over hundreds of millions of years. When tectonic plates slide beneath one another at subduction zones, they don't just carry rock into the interior. They carry vast amounts of seawater trapped in the pores of the stone and chemically bound within the minerals themselves. This water is dragged hundreds of kilometers down into the hot mantle, where it lowers the melting point of the surrounding rock, triggering the formation of magma that eventually rises to the surface as volcanic eruptions. In this way, every volcanic plume of steam is the Earth exhaling water that was once part of an ancient sea millions of years ago. Some geologists estimate that the Earth's mantle may actually hold as much water as all the surface oceans combined, hidden in the molecular structure of high-pressure minerals. This internal plumbing system acts as a giant stabilizer, ensuring that even as the surface changes, the planet maintains a consistent reservoir of the most vital ingredient for life. 52. The Earth's equatorial bulge means that the tallest mountain on Earth isn't actually Mount Everest. If you measure tallest as the point on the Earth's surface that is farthest away from the planet's center, the title doesn't belong to Everest in the Himalayas, but to Mount Chimborazo in Ecuador, because the Earth is an oblate spheroid, spinning so fast that it bulges at the equator. The surface of the planet at the equator is significantly farther from the core than it is at the poles. Chimborazo sits almost exactly on this equatorial spare tire. Even though its peak is only 6,263 meters above sea level compared to Everest's 8,848 meters, the bulge of the Earth gives Chimborazo a massive head start. Standing on its summit, you are technically closer to the stars and the vacuum of space than at any other point on the globe. It is a reminder that the very geometry of our world is dictated by the invisible forces of inertia and rotation, a planet shaped by its own momentum as it hurtles through the void at 107,000 kilometers per hour. 53. The Earth's lithospheric drag and the mystery of the missing day. We perceive the Earth's rotation as perfectly smooth, but on a microscopic scale, it is a constant struggle between the planet's core and its outer layers. The Earth's liquid outer core and its solid mantle don't always rotate at the exact same speed, creating a phenomenon known as core-mantle coupling. This friction, combined with the drag of the tides caused by the moon's gravity, acts like a set of slow-motion brakes on the planet. This internal and external resistance is so powerful that it causes the Earth's rotation to be slightly irregular. Occasionally, the planet stutters by a millisecond or two, requiring scientists to add a leap second to our atomic clocks to keep our time synchronized with the actual position of the Earth in space. As you sleep, you are riding on a 6 sextillion-ton machine that is fighting its own internal friction and the gravitational pull of the cosmos, a giant wheel that is very slowly, almost imperceptibly, grinding to a halt over billions of years. 54. The Earth's supercontinent cycle is a recurring grand reunion of all the world's landmasses. The current map of the world, with its 7 distinct continents separated by vast oceans, is merely a temporary arrangement in a cycle that repeats every 300 to 500 million years. Driven by the churning heat of the mantle, the continents are currently drifting away from the remains of the last supercontinent, Pangaea. However, because the Earth is a sphere, they eventually have nowhere else to go but back toward each other. Geologists have identified several past supercontinents with names like Rodinia, Columbia, and Kennerland. In about 250 million years, a new supercontinent, provisionally named Pangaea Proxima, is expected to form as the Atlantic Ocean closes and the Americas crash into Africa and Europe. This slow-motion collision will raise new mountain ranges taller than the Himalayas and create a massive, singular desert at the center of the world. A reminder that the solid ground beneath your bed is actually a wandering island in a multi-billion-year game of cosmic bumper cars. 55. The Earth's petrified sunlight is stored in the form of ancient fossil fuels. When you think of the energy that powers the modern world, you are essentially looking at stored sunlight from hundreds of millions of years ago. During the Carboniferous period, the Earth was covered in vast, swampy forests of giant ferns and club mosses. When these plants died, they didn't fully decay. Instead, they were buried under layers of sediment and cooked by the Earth's internal heat and pressure over eons. This process transformed the solar energy they had captured through photosynthesis into concentrated carbon, coal, oil, and gas. Burning these fuels today is, in a very literal sense, releasing the fossilized sunshine of a world that existed 300 million years before humans. It is a massive chemical battery that the Earth spent millions of years charging, providing a temporary burst of energy that represents the accumulated life force of an entire geological era. 56. The Earth's mineral evolution proves that life actually created the rocks we see today. For a long time, we thought minerals were just part of the dead, physical world, but mineralogists have discovered that most of the Earth's 5,000 plus mineral types could not exist without life. In the early days of the solar system, there were only about 250 basic minerals. It was only after life, specifically oxygen-producing bacteria, evolved that the Earth's crust underwent a great oxidation. This flood of oxygen reacted with existing elements to create thousands of new, colorful minerals like turquoise, malachite, and azurite. In fact, roughly 2/3 of all minerals on Earth are the direct or indirect result of biological activity. This means the very crystals and stones we find beautiful are the biomarkers of ancient life, a physical bridge between the biological and geological history of our home. 56. The Earth's mineral evolution proves that life actually created the rocks we see today. For a long time, we thought minerals were just part of the dead, physical world, but mineralogists have discovered that most of the Earth's 5,000 plus mineral types could not exist without life. In the early days of the solar system, there were only about 250 basic minerals. It was only after life, specifically oxygen-producing bacteria, evolved that the Earth's crust underwent a great oxidation. This flood of oxygen reacted with existing elements to create thousands of new, colorful minerals like turquoise, malachite, and azurite. In fact, roughly 2/3 of all minerals on Earth are the direct or indirect result of biological activity. This means the very crystals and stones we find beautiful are the biomarkers of ancient life, a physical bridge between the biological and geological history of our home. 58. The Earth's Coriolis force turns the planet into a giant, spinning laboratory of weather. Because the Earth is a rotating sphere, anything moving over its surface, like a gust of wind or an ocean current, is deflected by a phenomenon called the Coriolis effect. In the northern hemisphere, this force pulls moving air to the right, while in the southern hemisphere, it pulls it to the left. This is why hurricanes and typhoons spin in opposite directions depending on which side of the equator they form. Without this spin, the Earth's weather would be a simple, boring movement of hot air rising at the equator and sinking at the poles. Instead, the Coriolis force breaks the atmosphere into distinct cells of circulating air, creating the trade winds that guided ancient explorers and the jet streams that carry modern airplanes. As you sleep, the very rotation of the planet is sculpting the clouds into the beautiful, swirling patterns you see from space, a planetary dance governed by the physics of a spinning world. 59. The Earth's deep sound channel allows whale songs to travel across entire oceans. Deep within the ocean, between 600 and 1,200 meters down, there is a horizontal layer of water known as the SOFAR channel, sound fixing and ranging channel. Because of the specific way that temperature and pressure interact at this depth, the water acts as a waveguide, trapping sound waves and preventing them from scattering. Within this channel, sound travels with incredible efficiency. Scientists have found that the low-frequency calls of blue and fin whales can travel for thousands of kilometers through this layer, effectively allowing a whale off the coast of Africa to speak to another near Antarctica. It is a vast, invisible acoustic highway that has existed for millions of years, a silent submerged gallery where the planet's largest creatures sing to one another across the vastness of the abyss while we sleep in the world above. 60. The Earth's gravity anomalies prove that the planet's weight is not evenly distributed. While we often think of gravity as a constant, the Earth's pull is actually stronger in some places and weaker in others. This is because the Earth's crust and mantle vary in density. Regions with massive mountain ranges or thick slabs of subducted tectonic plates have more mass and therefore exert a slightly stronger gravitational tug. Conversely, deep ocean trenches or areas where the crust is thin have a weaker pull. Scientists use specialized satellites to map these gravity bumps and potholes, creating a model known as the gravity Earth. One of the most famous anomalies is in the Hudson Bay region of Canada, where gravity is significantly lower because the land is still depressed from the weight of the last great ice sheet. You are technically a tiny bit lighter or heavier depending on which part of the planet you are standing on, a subtle variation in the Earth's invisible grip. 61. The Earth's deep biosphere contains zombie microbes that live for thousands of years, kilometers beneath the seafloor. In the crushing pressure of the Earth's crust, scientists have discovered microbes that redefine our understanding of life. These organisms live in a world with almost no nutrients and no fresh oxygen. To survive, they have slowed their metabolism to a near halt, entering a state that researchers call living in slow motion. While a typical bacterium on the surface might divide every few minutes, these deep crust microbes may only divide once every few hundred or even thousand years. They aren't dead, but they aren't exactly active. They are zombie cells that have endured since the time of the ancient Egyptians, waiting in the silence of the stone for the slightest chemical change. They remind us that the Earth is not just a home for the fast and the vibrant, but a sanctuary for the patient and the eternal. 62. The Earth's atmospheric rivers carry more water than the world's largest oceans. In the sky above us, there are long, narrow regions in the atmosphere called atmospheric rivers that transport massive amounts of water vapor from the tropics toward the poles. These invisible rivers in the sky can be over 1,600 kilometers long and several hundred kilometers wide. A single strong atmospheric river can carry a flow of water vapor equivalent to 15 times the discharge of the Mississippi River. When these rivers hit mountain ranges, they release their moisture as torrential rain or heavy snow, providing essential water to regions like California or Western Europe. They are the planet's primary plumbing system for moving fresh water around the globe, ensuring that the moisture evaporated from the warm tropical seas eventually finds its way to the parched lands of the north and south. 63. The Earth's hidden glaciers are protected by blankets of rock and dust. Not all of the Earth's glaciers are the bright white sheets we see in photographs. In high-altitude deserts and mountain ranges, there are rock glaciers, massive bodies of ice that are buried under a thick layer of boulders, scree, and debris. This rocky armor protects the ice from the sun's heat, allowing it to survive in climates where a normal glacier would have melted long ago. These hidden reservoirs of water are critical to the survival of high mountain ecosystems, slowly releasing meltwater during the dry seasons to feed alpine streams. As the world warms, these rock-covered giants may become the Earth's final strongholds of frozen fresh water, a secret supply of life-giving ice tucked away beneath the rugged skin of the mountains. 64. The Earth's geologic clock is kept by the steady decay of radioactive atoms. While we use ticking gears or vibrating crystals to measure our days, the Earth keeps track of its vast history through the radiometric clock. Scattered throughout the crust are unstable isotopes of elements like uranium, potassium, and thorium. These atoms decay into stable daughter elements at an incredibly precise and unchanging rate known as a half-life. By measuring the ratio of parent atoms to daughter atoms trapped inside a crystal, geologists can determine exactly when that rock cooled from a molten state. This is how we know the Earth is 4.54 billion years old. It is a silent, atomic ledger that has been recording the passage of eons with unwavering accuracy, ensuring that the story of every mountain and every ancient seabed is dated to the very million-year mark. 65. The Earth's green flash is a rare atmospheric prism effect at the edge of day. As you drift off, imagine the very last sliver of the sun disappearing below a flat ocean horizon. For a fleeting second, a brilliant, emerald green spot of light may appear right at the top edge of the sun. This is the green flash. It happens because the Earth's atmosphere acts like a giant prism, bending or refracting the sun's light. As the sun sets, the atmosphere bends the shorter wavelengths of light, like green and blue, more than the longer red wavelengths. Under just the right conditions of clear air and temperature, the red and orange light disappears first, leaving a momentary spark of pure green. It is a beautiful, optical goodbye from the atmosphere, a quiet reminder of the physics of light that governs our transition from day into night. 66. The Earth's deep-sea brine pools are underwater lakes within the ocean. Deep on the floor of the Gulf of Mexico and the Red Sea, there are literal lakes with shorelines, waves, and surfaces, all located thousands of meters under the sea. These are brine pools. They form when ancient salt deposits beneath the seafloor dissolve, creating water that is 4 to 5 times saltier than the surrounding ocean. Because this brine is so much denser than seawater, it doesn't mix. It settles into depressions, forming distinct pools with their own unique chemistry. These pools are toxic to most fish, but they are surrounded by specialized mussels and bacteria that thrive in the extreme environment. They are a surreal world within a world, a hidden landscape where the laws of density create a lake on the bottom of the ocean. 67. The Earth's Tropic of Cancer and Capricorn mark the limits of the sun's overhead journey. The Earth is tilted on its axis by about 23.5 degrees, and this tilt is what creates our seasons. Because of this lean, there are 2 invisible lines on the globe, the tropics, that mark the farthest points north and south where the sun can ever appear directly overhead. On the summer solstice, the sun is directly above the Tropic of Cancer. On the winter solstice, it shines straight down on the Tropic of Capricorn. Everything between these 2 lines is the torrid zone, the tropical heart of the planet, where the sun's energy is most intense. This tilt is the planet's pulse, the reason we have the changing colors of autumn and the rebirth of spring, a celestial geometry that dictates the rhythm of all life. 68. The Earth's regolith is the dusty blanket that protects the planet's skeleton. Beneath the organic soil and above the solid bedrock lies a layer of loose, fragmented material called regolith. This is a mixture of broken rock, dust, and volcanic ash that has been created by millions of years of weathering and meteor impacts. While we have regolith on the Moon and Mars, Earth's regolith is unique because it is constantly being moved and chemically altered by water and wind. It acts as a protective buffer, a soft cushion that hides the planet's hard skeleton of granite and basalt. Every time you dig a hole or look at a construction site, you are seeing the regolith, the planetary dust that has accumulated over billions of years, providing the foundation for the thin layer of life that exists on the surface. 69. The Earth's atmospheric whispering gallery allows sound to travel through the sky. Just as the ocean has the SOFAR channel, the atmosphere has a layer where sound can travel incredible distances. High in the stratosphere, temperature and wind patterns create a duct that can trap low-frequency sounds, often called infrasound. These sounds, produced by massive events like volcanic eruptions, lightning strikes, or even the crashing of large ocean waves, can bounce between the ground and the upper atmosphere, traveling thousands of kilometers. While these sounds are too deep for you to hear, sensitive scientific instruments can listen to a volcano erupting on the other side of the world, a silent, invisible symphony of pressure waves rippling through the thin air while the world sleeps. 70. The Earth's lava tubes are giant, hidden veins from its volcanic past. Beneath the surface of volcanic regions like Hawaii, Iceland, and the Canary Islands, there are vast, hollow cathedrals known as lava tubes. These form during eruptions when the outer layer of a lava flow cools and hardens into a solid crust, while the molten rock inside continues to flow like a river. Once the eruption ends, the lava drains out, leaving behind a smooth, tunnel-like cave that can stretch for miles. Some of these tubes are large enough to fit an entire subway train. They act as perfect insulators, and in some cold climates, they trap ice that stays frozen all year round, even in the middle of a desert. They are the empty veins of the planet, reminders of the fiery blood that once moved just beneath the skin of the Earth. 71. The Earth's primary and secondary waves tell us what's inside the core. We know the Earth has a liquid outer core because of how it reacts to S-waves during earthquakes. When an earthquake strikes, it sends out 2 types of body waves: P waves, primary, and S waves, secondary. P waves can travel through both solids and liquids, but S waves, which move in a side-to-side shearing motion, cannot pass through liquid. Seismologists notice that when an earthquake happens, S waves completely disappear when they hit the core, leaving a shadow zone on the other side of the planet. This is the proof that our planet contains a massive, Molten sea of iron 2,900 kilometers down. A liquid barrier that blocks the vibrations of the solid Earth. 72. The Earth's global electrical circuit is a constant battery being charged by lightning. At any given moment, there are roughly 2,000 thunderstorms active around the globe, producing about 100 lightning strikes every second. This constant activity acts like a giant battery charger for the planet. The Earth's surface is negatively charged, while the upper atmosphere, the ionosphere, is positively charged. Lightning acts as the wiring that returns the charge to the ground, maintaining a steady electrical current that flows through the air everywhere, even in fair weather. You are sleeping inside a massive, natural electrical circuit, a planetary-scale capacitor that is constantly sparking and recharging in a restless, energetic balance. 73. The Earth's speleothems are stone clocks that record the rainfall of the past. Deep inside limestone caves, stalactites and stalagmites, collectively called speleothems, grow at an agonizingly slow rate, often just a few millimeters every century. As rainwater drips into the cave, it carries minerals and chemical signatures from the surface. By slicing a stalagmite open and looking at its growth rings, much like a tree, scientists can determine how much it rained thousands of years ago. These stone clocks can reveal ancient droughts, floods, and changes in vegetation, providing a high-resolution history of the Earth's climate that is safely tucked away in the darkness and silence of the subterranean world. 74. The Earth's magnetic memory is locked within the tiny iron skeletons of ancient bacteria. One of the most profound ways the Earth records its history is through a phenomenon called paleomagnetism. But it isn't just rocks that act as recorders. Certain types of magnetotactic bacteria have evolved to grow tiny, internal chains of magnetite crystals, essentially microscopic compass needles. These bacteria use the Earth's magnetic field to navigate through the muck of lakes and oceans to find their preferred oxygen levels. When these bacteria die, their tiny magnetic skeletons sink to the floor and become part of the sedimentary rock. Because these crystals align with the magnetic North Pole at the moment of the bacteria's death, they provide a permanent record of where the Earth's magnetic field was pointing millions of years ago. By studying these biogenic magnets, scientists can track the movement of continents and the flipping of the magnetic poles with incredible precision. It is a staggering thought that the orientation of our entire planet's magnetic shield is preserved in the fossilized remains of organisms too small to be seen by the naked eye, a microscopic library of the Earth's invisible forces. '75. The Earth's teethest sea is a ghost ocean whose remains now sit atop the world's highest mountains. Millions of years ago, a vast, tropical body of water known as the teethest sea separated the ancient supercontinents of Laurasia and Gondwana. This ocean was a warm, shallow cradle of life, filled with coral reefs and prehistoric marine creatures. However, as the tectonic plate carrying India moved northward and collided with Asia, the teethest sea was slowly squeezed out of existence. The tremendous force of this collision didn't just destroy the ocean. It buckled the seafloor, thrusting the ancient limestone and the fossils of marine life up into the sky to form the Himalayan mountain range. This is why, if you were to climb to the high ridges of the Himalayas, you would find the fossilized shells of ammonites, extinct sea creatures thousands of meters above sea level. The roof of the world is literally built from the graveyard of a vanished ocean, a testament to the Earth's ability to turn the deepest depths into the highest peaks through the slow, relentless power of geological time. 76. The Earth's atmospheric escape means our planet is slowly leaking into the vacuum of space. Despite the strong pull of gravity, the Earth is not a perfectly sealed vessel. It is constantly losing a tiny fraction of its atmosphere to the void. This process, known as atmospheric escape, occurs primarily with the lightest elements, hydrogen and helium. High in the exosphere, individual molecules can gain enough energy from solar radiation to reach escape velocity, breaking free from Earth's grip forever. Scientists estimate that the Earth loses about 95,000 tons of hydrogen gas every year. While this sounds like a massive amount, the Earth is so large that it would take trillions of years to completely strip the atmosphere at this rate. Interestingly, while we lose light gases, we gain mass from falling space dust, creating a complex weight balance for the planet. As you sleep, a thin, ghostly trail of our atmosphere is streaming out behind the Earth like a comet's tail, a quiet dissipation of our world into the cosmic neighborhood. 77. The Earth's deep Earth oxygen may be hidden in the crystalline structure of the mantle. For decades, we believed that all of the Earth's oxygen was concentrated in the atmosphere and the crust, but new high-pressure experiments suggest that a massive reservoir of oxygen might be trapped 2,000 kilometers beneath our feet. In the extreme heat and pressure of the lower mantle, minerals undergo phase transitions, changing their crystalline structure. Researchers have found that a mineral called iron peroxide can exist at these depths, holding onto oxygen atoms that would otherwise be released as gas. If these findings are correct, the Earth's mantle could be holding more oxygen than our entire atmosphere, acting as a deep-seated chemical buffer. This oxygen could occasionally be released during massive volcanic events, influencing the chemistry of the surface over millions of years. It suggests that the breadth of our planet is much deeper and more complex than we ever imagined, with the very rocks of the interior acting as a hidden lung for the world. 78. The Earth's glacial isostatic adjustment is causing the planet to change its shape as you sleep. The Earth is still recovering from the weight of the massive ice sheets that covered much of the northern hemisphere during the last ice age. This process, called glacial isostatic adjustment, is a slow-motion bouncing back of the Earth's crust. Because the mantle beneath the crust behaves like a very thick, viscous liquid, it takes thousands of years for it to flow back into place after the ice melts. As regions like Canada and Scandinavia rise upward, other areas on the edges of the former ice sheets, like the US East Coast, are actually sinking slightly to compensate. This movement is so significant that it actually affects the Earth's moment of inertia, causing a slight shift in the way the planet rotates on its axis. We are living in the aftermath of a frozen era, a world that is still subtly shifting, rising, and settling as it seeks a new equilibrium in a warmer age, a silent mechanical adjustment of the planet's very form. 79. The Earth's hadal zone and the terrifying pressure of the deep-sea trenches. Deep beneath the surface of the ocean, beyond the midnight zone, lies the hadal zone, named after Hades, the Greek god of the underworld. This region consists of the planet's deepest oceanic trenches, such as the Mariana Trench, which plunges nearly 11,000 meters into the crust. At these depths, the weight of the water column above creates a pressure of over 1,000 atmospheres, roughly 15,000 pounds per square inch. To put this into perspective, being at the bottom of the trench is equivalent to having an elephant stand on your thumb or trying to support the weight of 50 jumbo jets. Despite this crushing force, the Earth has cultivated life here. Translucent snailfish, giant amphipods, and xenophytophores, single-celled organisms the size of a dinner plate, thrive in the darkness. These trenches are the recycling bins of the planet. As tectonic plates are pushed down into the mantle at these sites, they carry carbon, water, and organic matter back into the Earth's interior, acting as the primary gateway between the biological world and the geological furnace of the mantle. 80. The Earth's geothermal gradient and the internal fire beneath your feet. As you descend into the Earth, the temperature rises at a remarkably steady rate known as the geothermal gradient. On average, for every kilometer you go down, the temperature increases by about $20 /circ \text $C$ to $30 /circ $text $C$, $77 /circ $text F$ to $86 /circ $text F$ per mile. This means that just a few kilometers below the surface, well within the reach of modern drilling technology, the rocks are hot enough to boil water instantly. This heat is a combination of the primordial heat left over from the planet's violent birth and the radiogenic heat produced by the decay of elements like uranium-238 and thorium-232. In some regions, like Iceland or the western United States, this heat sits much closer to the surface, allowing us to tap into geothermal reservoirs for clean energy. This gradient is the reason the Earth's core remains molten while the surface is frozen. We are living on a thin, fragile crust that acts as a thermal blanket, insulating us from a core that is as hot as the surface of the sun. $5 500-circ/text $81. The Earth's Precambrian shield is the indestructible foundation of the continent. While much of the Earth's surface is covered in young sedimentary rocks or soil, every continent has a shield, a massive, exposed area of ancient crystalline rock that has remained tectonically stable for billions of years. The Canadian shield, the African shield, and the Australian shield are the cratons, or the original building blocks of the continents. These rocks, mostly granites and gneisses, date back to the Archean up to 4 billion years ago, and have survived the breakup of supercontinents, the carving of glaciers, and the rise and fall of countless mountain ranges. They are incredibly rich in metals like gold, nickel, and iron because they formed during a time when the Earth's chemistry was more metallic and volatile. When you stand on a shield, you are standing on the old growth of the planet, the sturdy, unyielding skeleton that has held the continents together through almost the entire history of life on Earth. '82. The Earth's global conveyor belt is a massive underwater river that takes 1,000 years to complete a single circuit. While the surface currents of the ocean are driven by the wind, the deep ocean is moved by a colossal, three-dimensional system called thermohaline circulation. This conveyor belt is powered by differences in water temperature, thermo, and saltiness, haline. It begins in the cold North Atlantic, where sea ice forms, leaving behind saltier, denser water that sinks to the bottom of the ocean like a heavy stone. This sinking water creates a pull that draws warm water from the tropics, including the Gulf Stream, northward, which is the only reason northern Europe remains habitable and relatively warm. This deep, cold current then crawls along the ocean floor, traveling all the way past the tip of Africa and into the Indian and Pacific Oceans before finally welling back up to the surface centuries later. It is a slow, majestic circulation of the planet's lifeblood, ensuring that heat and nutrients are distributed globally, acting as a massive thermal regulator that keeps the Earth's climate from swinging into wild extremes. '83. The Earth's paleosoils are ancient, fossilized dirt layers that act as chemical diaries of extinct climates. Deep within the layers of sedimentary rock, geologists find paleosols, ancient soils that were formed on the Earth's surface millions of years ago and then buried and turned to stone. These aren't just rocks. They are the literal skin of the ancient Earth preserved in time. By studying the minerals and root traces in these paleosols, scientists can reconstruct exactly what the environment was like when they formed. They can determine the annual rainfall of the Jurassic period, the carbon dioxide levels during the age of the dinosaurs, and even what kinds of microbes were present in the soil billions of years ago. These layers of fossilized dirt are the only physical records we have of the Earth's ancient land surfaces, providing a window into the terrestrial history of the planet that the more common marine fossils cannot offer. They remind us that the ground we walk on is just the latest in a long, stacked history of grounds that have supported life for eons. '84. The Earth's Milankovitch cycles are the celestial gears that trigger the coming and going of ice ages. The Earth's climate isn't just determined by what happens on the surface. It is governed by a set of 3 long-term wobbles in our orbit around the Sun, known as Milankovitch cycles. First is the eccentricity, where the shape of Earth's orbit changes from a circle to an oval over 100,000 years. Second is the obliquity, the change in the tilt of the Earth's axis every 41,000 years. Third is the precession, the way the Earth wobbles on its axis like a spinning top every 26,000 years. When these 3 cycles align in a specific way, they reduce the amount of solar energy reaching the northern hemisphere during the summer, allowing snow to survive through the year and eventually build up into massive glaciers. We are currently living in a warm interglacial period, but these silent, celestial gears are always turning, slowly shifting the planet's orientation and distance from the Sun, setting the stage for the next great freeze thousands of years into the future. '85. The Earth's banded iron formations are a colossal, rust-colored monument to the moment life changed the world's chemistry. Hidden within the ancient rock layers of Western Australia and the shores of Lake Superior are the banded iron formations, BIFs. Striking, zebra-striped rocks of alternating silver-gray magnetite and deep red chert. These formations are not just beautiful. They are the physical records of the single most important biological event in our planet's history, the Great Oxygenation Event. Over 2.4 billion years ago, the Earth's oceans were filled with dissolved iron, making the waters a murky green. When ancient cyanobacteria evolved the ability to perform photosynthesis, they began pumping a new poison into the sea: oxygen. This oxygen reacted with the dissolved iron, causing it to rust and settle onto the ocean floor in massive layers. For hundreds of millions of years, this process continued, effectively cleaning the oceans of iron and building up the world's largest iron ore deposits. The very same iron we mine today to build our skyscrapers, cars, and bridges. Once the iron in the oceans was completely oxidized, the oxygen finally began to leak into the atmosphere, creating the blue sky we see today and paving the way for all complex, oxygen-breathing life. Every steel beam in every building on Earth is a piece of that ancient, biological revolution, a silent witness to a time when microscopic life rewrote the chemical laws of the planet. 86. The Earth's geoid reveals that our planet is actually a lumpy potato of gravity. While we often imagine the Earth as a smooth, perfect marble or even a slightly squashed oblate spheroid, its true physical shape, defined by gravity, is far more complex and irregular. Scientists call this shape the geoid. The geoid is a model of what the Earth's surface would look like if the oceans were shaped only by gravity and the rotation of the Earth, ignoring winds and tides. Because the density of the Earth's interior is not uniform, with massive mountains of dense rock in the mantle and varying thicknesses of crust, the pull of gravity changes from 1 square mile to the next. In areas with high mass, like the Himalayas or the North Atlantic, gravity is slightly stronger, causing the sea level to bulge upward. In areas like the Indian Ocean, there is a massive gravity hole, where the surface of the ocean actually sits about 100 meters lower than the average. These gravitational valleys and mountains are invisible to the naked eye because the water follows the curve of gravity perfectly, but they are vital for satellite navigation and our understanding of deep Earth density. As you lie in bed, you are resting on a planet that is constantly pulling on you with a force that is unique to your specific latitude and longitude. The geoid is the true face of the Earth's mass, a hidden, lumpy geometry that maps the restless distribution of matter deep within the planet's heart. 87. The Earth's ludiclines and the eerie phenomenon of the false bottom that haunted early oceanographers. In the mid-20th century, as sonar technology began to mature, sailors and scientists were baffled by a recurring anomaly. Their depth finders would often report a solid seafloor at only a few hundred meters deep. Yet when they returned to the same spot hours later, the floor would have vanished or descended into the abyss. This phenomenon, which became known as the deep scattering layer, was eventually revealed to be a massive, living ludicline, a sharp gradient of suspended organic matter and trillions of small organisms, such as lanternfish and krill. These creatures gather in such dense concentrations that they create a biological false bottom that reflects sonar waves back to the surface. By day, this layer hides in the dark, cold depths to avoid predators. But as the sun sets, it begins the great vertical migration, the largest movement of biomass on Earth, rising toward the surface to feed. This ghostly, moving ceiling of life acts as a physical barrier in the water column, separating the sunlit world from the deep and recycling massive amounts of carbon as it pulses up and down in a rhythmic, daily heartbeat that early explorers once mistook for the very foundation of the Earth. 88. The Earth's carbonate compensation depth is the invisible line where the ocean dissolves its own history. Deep in the ocean, there is a ghostly boundary known as the carbonate compensation depth, CCD. Above this line, the seafloor is often covered in calcareous ooze, a white, chalky sediment made of the tiny shells of dead plankton. However, because cold, deep water is more acidic and holds more $CO_2, there comes a point, usually between 4,000 and 5,000 meters, where the water becomes so corrosive to calcium carbonate that shells dissolve faster than they can accumulate. Below this depth, the seafloor changes color from brilliant white to a dark, rusty abyssal clay. It is a chemical finish line where the biological record of the surface is systematically erased by the chemistry of the deep, leaving the deepest trenches of the world devoid of the limestone skeletons that build the shallower mountains. 89. The Earth's paleoequator shows that the North Pole was once a tropical paradise. Because the Earth's tectonic plates wander across the globe, the landmasses we now associate with freezing temperatures were once positioned at the equator. Geologists have found fossilized palm trees and remains of ancient crocodiles in the Canadian Arctic and coal seams in Antarctica. By studying the magnetic orientation of rocks, paleomagnetism, scientists can map the paleoequator, the position of the Earth's belt at different points in history. This reveals that for much of the planet's life, there were no permanent polar ice caps, and the tropical zone stretched nearly to the poles. The current frozen state of our poles is actually a relatively rare occurrence in the grand multi-billion-year timeline of the Earth's climate. 90. The Earth's zircon time capsules are the only survivors from the planet's birth. Most of the rocks from the first 500 million years of Earth's history, the Hadean, have been destroyed by erosion or recycled by plate tectonics. However, tiny, near-indestructible crystals called zircons have survived. These crystals are smaller than a grain of sand, but they are so hardy that they can survive being melted, crushed, and eroded. By analyzing 4.4 billion-year-old zircons found in Australia, scientists discovered that the early Earth wasn't just a sea of molten lava. It actually had liquid water and potentially even continents much earlier than we thought. These microscopic gemstones are the oldest witnesses, the only original physical material left from the very first days of our world. 91. The Earth's Anthropocene layer is the thin, plastic-tinted signature we are leaving behind. If a geologist from the distant future were to dig into the Earth, they would find a distinct, paper-thin layer representing our current era. This is the Anthropocene marker. It consists of a unique chemical cocktail that has never existed before: radioactive isotopes from 20th century nuclear tests, microscopic bits of plastic, microplastics, high concentrations of nitrogen from synthetic fertilizers, and the remains of billions of domestic chickens, now the most numerous bird on Earth. This layer is a global footprint, a permanent geological scar that marks the moment a single species began to alter the physical chemistry of the entire planet, moving more sediment and rock every year than all the world's rivers combined. 92. The Earth's atmospheric window for radio is our only natural peephole into the deep universe. The atmosphere is mostly opaque to the vast majority of radiation from space, but it possesses a radio window that allows long wavelength radio waves to pass through completely unhindered. This is why we can build massive radio telescopes on the ground to listen to the birth of stars and the echoes of the Big Bang. While clouds and rain block our visual view of the stars, the radio sky is always clear. This window is a cosmic coincidence. If our atmosphere were just a little thicker or had a different chemical makeup, we might be trapped in a blind world, unaware that the universe around us is filled with the rhythmic pulsing of pulsars and the radio frequency whispers of distant galaxies. 93. The Earth's deep Earth diamonds are high-speed messengers from the mantle. Most diamonds aren't formed in the crust. They are forged in the diamond stability zone, located about 150 to 200 kilometers below your feet, where pressures are 50,000 times greater than at the surface. They only reach us through rare, violent volcanic eruptions called kimberlite pipes, which travel at speeds approaching the speed of sound. These diamonds often carry inclusions, tiny flaws that are actually fragments of the deep mantle trapped inside. Recently, a diamond was found containing a mineral called ringwoodite, which was found to be 1.5% water by weight. This suggests that there is a deep ocean worth of water trapped in the crystal structures of the mantle's rocks, not as a liquid, but as a chemical ingredient in the stone itself. 94. The Earth's second moon, Cruthen, is a celestial companion in a horseshoe dance. While the moon is our only permanent satellite, Earth frequently captures mini-moons or shares its orbit with quasi-satellites. The most famous is 3753 Cruthen, a 5-kilometer wide asteroid. Cruthen doesn't orbit the Earth in a circle. Instead, it shares Earth's orbit around the Sun in a complex horseshoe pattern, From our perspective, it looks like it's following us, but it actually takes a bean-shaped path that brings it close to Earth and then flings it away over a 770-year cycle. It is a reminder that we aren't alone in our journey. Our gravity is constantly tugging at the debris of the solar system, momentarily catching companions before letting them go back into the void. '95. The Earth's seismic anisotropy reveals the hidden grain of the inner core. As you descend to the very center of the Earth, you find a solid ball of iron and nickel the size of Pluto. This is the inner core. Seismologists have discovered something strange. Earthquake waves travel faster through the core from north to south than they do from east to west. This is called seismic anisotropy. It suggests that the iron crystals in the inner core are all aligned in a specific direction, like the grain in a piece of wood. This alignment is likely caused by the Earth's rotation and its magnetic field, meaning the very heart of our planet is a giant, structured crystal that has been growing for over 1 billion years as the liquid outer core slowly freezes onto it. 96. The Earth's teleseismic ghosting and the echo of the world's biggest quakes. When a massive earthquake, magnitude 8 or higher, occurs, the energy doesn't just dissipate locally. The entire planet rings like a bell. These waves, called teleseismic waves, travel through the center of the Earth and can be detected on the exact opposite side of the globe, the antipodes. What is truly haunting is that these waves can echo. They can circle the circumference of the Earth multiple times, getting weaker with each pass, but still detectable by sensitive instruments hours later. As you sleep, the Earth might still be humming from an earthquake that happened 12 hours ago on the other side of the world, a silent vibration passing through your room and moving toward the stars. 97. The Earth's desert varnish is a biological ink that takes thousands of years to dry. In the world's driest deserts, you'll often see rocks covered in a dark, shiny, manganese-rich coating called desert varnish. For centuries, scientists thought this was a purely chemical reaction. We now know it is likely produced by specialized lithotrophic bacteria that live on the rock surface. They slowly concentrate minerals from the wind-blown dust to build a protective shield against the harsh UV rays of the sun. This varnish grows at an incredibly slow rate, only a few micrometers every 1,000 years. When you see ancient petroglyphs carved into a canyon wall, you are looking at art made by scraping away a biological ink that the Earth spent 10,000 years carefully painting onto the stone. 98. The Earth's ludiclines and the internal waves that move beneath the surface. While we are familiar with the waves that crash onto the shore, the Earth's oceans contain even more massive internal waves that occur at the boundaries between layers of different density, known as ludiclines, sediment density, or pycnoclines, temperature/salt density. These invisible waves can be hundreds of meters high, yet they are barely detectable on the surface. They are often triggered when tidal currents push deep water over underwater mountain ranges. These massive, slow-motion undulations are responsible for mixing the ocean's nutrients and heat, acting as a deep tissue massage for the planet's seas. Because they change the density of the water column, they can actually affect the navigation of submarines, which can find themselves suddenly sinking or rising as they ride these hidden, underwater swells. 99. The Earth's technosignatures and our planet's growing radio shell. Since the invention of radio and television, the Earth has been leaking electromagnetic radiation into space, creating an ever-expanding radio shell that is now over 100 light-years in diameter. To a distant observer with a sensitive enough telescope, the Earth would stand out not because of its light, but because of its technosignatures, the artificial, non-natural radio frequencies we broadcast. This shell contains the echoes of 1940s news broadcasts, 1980s sitcoms, and modern satellite data. We are effectively announcing ourselves to the galaxy, a blue marble wrapped in a growing cocoon of information that travels at the speed of light, carrying the story of our civilization to stars we have never even visited. 100. The Earth's ultimate fate and the long journey toward the sun. In the very distant future, about 5 billion years from now, the sun will run out of hydrogen and begin to expand into a red giant. As it grows, it will likely consume the inner planets, Mercury and Venus. The Earth's fate is a subject of intense scientific debate. The sun's expansion might engulf the Earth entirely, vaporizing the rocks that have held our history for eons. However, as the sun loses mass, its gravitational pull will weaken, potentially allowing the Earth to drift further away into a wider orbit. Even if the Earth survives being swallowed, the intense heat will boil away the oceans and strip the atmosphere, leaving behind a scorched, airless cinder. It is a poignant reminder that our planet is a temporary sanctuary, a beautiful, fragile, and miraculous accident in the vast, unfolding timeline of the cosmos. The screen dims to the soft, rhythmic pulsing of the Earth's magnetic field, a final reminder of the invisible forces that cradle us. The vast, deep water reservoirs, the wandering continents, and the zombie microbes in the crust all fade into a peaceful, cosmic stillness. As the last flicker of the green flash disappears from the horizon, the planet settles into its nightly rotation, a silent guardian moving through the stars. The journey through these 100 wonders concludes here, but the story of the Earth continues with every breath you take and every mile the planet travels. Good night.